Okay, Bismillahirrahmanirrahim. So today we will be discussing about the water demand. So I will. It's basically the chapter of the introduction of urban water distribution system. It's a book, and I can't go through in much detail by just reading through each point. I will go through it in a summarized way. Mata connection masala ki tas to आवाज दर्जी करना जी. Hello.
रजी आवाज रजी
Okay. So we will just I will give you the explanation in a summarized way of different topics involved in this chapter. So basically water production is the water basically produced from the treatment facility. For example, if you have installed a treatment facility to treat a water, if the water available in a source have not of viable quality, then you provide a water treatment facility. So water production is basically the water producing by a treatment facility you have provided for a water supply network. Water delivery is basically the water transfer or supply from a reservoir or a treatment facility to a specified point or the consumption point where you have to provide a water for a community. So basically water delivery is basically you have to supply your water through some way like a pipe. So if the consumption area is near to the treatment plant or the source, so you can directly supply the water to distribution network, or if it is far away from the source, then you can provide an intermediate tank, and then through intermediate tank you can fulfill the demand of your community. Water consumption is basically the water consumed by the people or the animals or the different stuff, like for example in an industry you are making different type of material, so the water consumed in different types of activities. So that type of water consumed by the consumer in a different activities is called the water consumption. And the water leakage is basically the water physically lost from the system, so the loss of water is called the water leakage. And water demand is basically the sum of water consumption and the sum of water leakage. So average the okay, I want to see the pencil. So water demand and average demand and the specific demand, there's a difference between in these two. So average demand is basically, for example, you calculate a demand for a whole day. So the demand, for example, I will just in a simple way will be like the liter per day will be an average demand. If you divide the average per day demand based on the number of people you are providing to it, for example, if you are providing the water for 100 people, so the by dividing these liter per day by a capita, so it becomes liter per capita per day. So the liter per capita per day is basically the specific demand, while the liter per day is basically the average demand. So average demand is basically calculated if mostly in developed countries, they have provided a meters just like we have the WAPDA or the PESCO have provided electricity meters for calculating that how much electricity is using by the customer. So in that way, the developed countries have also provided customer meters at each house, and they daily calculate that how much water is consuming by a consumer. So based, for example, if I get a data for a whole day based on hourly, like for a 1 hour, these are 24 hours. So for each hour, the data is calculated, and then take an average for that some of the water consumed by the consumer for the whole day and divided by 24, we get the liter per day. So just like that, it is called the water average demand, and then divided by the total number of people consuming that demand is called the specific demand, known as the liter per capita per day. So these are some terminologies I want to explain it to you. Similarly, in this chapter, we will be discussing about some case studies to show you that how the demand is calculated and what are the diurnal patterns and how we will calculate the demand for our water supply network. So this is a study basically conducted for water demand in Netherlands. So this is a total water delivered by the water companies about of 1,247 million meter cube. So some of the water is basically provided for the drinking purposes. So by subtracting that water is basically using for other purposes, while the drinking water paid for by user. So that amount of water is being paid by the consumer, while some of the amount by subtracting. In these two, we get about 48 million meter cube. That is basically maybe the loss or maybe the water consuming by the consumer having not paying to the government. While some of the consumer below 1,000, basically these two values are the last two groups in the table coincide with the commercial and domestic water use. So these basically based on the per connection, because the commercial and the both domestic and the commercial uses are connected to that connection, therefore the consuming of water per year is high. So these values basically shows for that the commercial and the domestic water use. Similarly, if you want to design a water supply network, then you have to think about that for what purpose you have to design a water supply network. And similarly, you have to know that who is the user. That, for example, you are providing water for industrial, that how much their industrial facilities or the factories are there in that community or that specific zone, or for example, or the how much markets or shops are there are in there, or how much schools, colleges, universities, institutions, offices, hotels, similarly like guest houses, homes, different type of. So you have to look all of these different type of demands. So based on that, you have to design a water supply network. So how valuable is the water? So means that the water may be used under some circumstances that restrict the demand. For example, the valuability depend upon the how much the what is available in that area, the quantity, and also if it is available in a very high quantity but not able to use for different purposes. You can observe in a Karachi that the amount of water is high, but the quality of that water is not that much good that you can use it for the drinking purposes, and mostly you can't use also as for the bathing purposes like that. So the variability depend upon the quantity as well as the quality, and also depend upon the standard living of a person or consumers in a community. So these are basically domestic consumptions of different states, of different cities in Asia. So basically, we will be using mostly the value that are used for the design of water supply network is about 135 liter per capita per day. So mostly that value is basically calculated by the Indians. So that type of values you may use. You can basically we will be using the value which we have provided by the standards of our Punjab government. So mostly people also use the 135 liter per capita per day. Mostly the standard living of the Indians peoples are same as ours. Therefore, you can also use that value, but it will be more good that if you use the value provided by the standard of the specific, for example, the PhD department or the other department related to it. So you can observe that for the Delhi, the consumption calculated is about the 135 liter per capita per day, and for the Karachi, the capita per demand is also calculated. So based on these values, for example, if you are doing a design for in Karachi, then you can use these values as well. This values because varies from city to city, and the consumption demand also varies from the from home to home, and from the city to city, from the country to country. So it varies. Assalamu alaikum. Kazim bhai zula class salam abiyat astazudakum sayida. So you can observe the specific demand for in Africa. So that in Asian country, that per capita consumption is much higher than the per capita consumption than the Africa countries. So it's also depend upon the quality and quantity of water available in that area. So unaccounted water for water is basically the water which is not paid by the consumer, or the water lost in leakage. Okay, water used by various sectors. So the by sector to sector, the water consumption also varies. So you can observe from the graph that this is basically the statistical values calculated in the Netherlands. So for the non-domestic value, for the non-domestic and domestic, you can observe that the from year to year, from time to time, as the area developed, so the consumption based on the domestic or the non-domestic also varies. Similarly, for the different type of purposes, if you are using water for agriculture, industries, domestic, so from the consumption base, you can the demand also varies, and the demand is also varying based on the by different states of the Africa. So basically, I want to show you in this lecture that if you want to design a water supply network, so you have to keep these different type of factors in your mind. That first of all, you have to analyze that what type of facility, if for what purpose you are want to design, that it consists of number of factors. So to design a water supply network for these factors. So domestic consumption for the different countries, it also varies. So I will give you this book, and you can read it in detail about each step, each topic. So I'm just giving you a summary of this chapter. Okay, from this graph, you can also observe that the increasing the number of people in a house also affect the consumption liter per capita per day. By age categories, the water consumption also varies. Similarly, for different regions, for different income categories, the consumptions also varies. Not domestic consumption. So basically, if you are to design, if the industry is also included in your in your the jurisdiction of your water supply network, then you have all to you have to first consider that what type of industry are there in your that specific region of your desired water supply network. So, for example, if there is the carbonated soft drink industry, fruit juices, beer, so based on that, you have to consider the demand per unit product, and then you have to also calculate that how much product per day the industry are producing. So based on that, you have to take the demand, and that demand you have to provide on a node. So for agriculture purposes, so for a different type of the crops, the demands also varies season to season. So some crop cultivated throughout the year, then some are about 75 to 110 days per year. So it also varies. So you have to also keep to, for example, if you are designing a water supply network for the agriculture purposes, or you are providing a channel network for that, for example, you are designing a channel network. So basically, this is not the topic, the course about the open channel flow. So I'm just giving you a clue about that. That if you are designing a water open channel for the agriculture purposes, so you have to keep these factors in mind in order to design in that for that purpose. You have to keep also, for example, if you are if there is a farm in your uh, uh, region of water supply network, then you have also consider that basic form, for example, is the form of cows, oxen, horses, pigs, sheep, goats. So these are the different types of animals that you have to consider, and you also have to find the number of cows and oxen, horses in that form in order to calculate the liter per day demand. You have also considered institutions, the tourism areas, and the other miscellaneous groups like schools, hospitals, laundries, small businesses, retail shops, offices. Okay, so how basically the liter per capita demand is calculated? So it's a problem. Our water company, supply company, has delivered an annual quantity of 80 million meter cube to a city of that amount of inhabitants, find out the specific demand in the distribution area. In addition, calculate the domestic consumption per capita with leakage from the system estimated at 15% of the total supply and build non. So we have to first calculate the specific demand. To calculate the specific demand, what you have to do, so this is basically the annual supply of water to the city. So divide that annual supply by the inhabitant, we get the average supply, average demand. So by dividing the volume of that water which is supplying to the city by dividing by the number of inhabitants you have providing that water, multiplying with 1000 in order to convert into the liter, and divided in the 365 to convert the annual, the year to the day. So liter per day, liter per capita per day. So this is basically the specific demand. So in order to calculate the domestic demand, so first you have to also calculate the how much water is lost in due to the leakage, and also that the water is used for the non-domestic purposes like for the factory industry, from the farm, for the hospital, and similarly for the school colleges. So that type of consumption is given to you. So to calculate the domestic demand, multiplying the 15% of 15% of the leakage with the this amount, and then divided by the year, you can into whatever. So just multiply the 15% with the volume of water you are providing to the city. You will get the value that how much volume of water is we are losing from the network, reducing the total figure. So domestic consumption is the annual domestic consumption of. So you have to subtract that how much amount of water you are supplying to the network, to the community, then subtracting the loss of water, and also subtracting the water that are used for not domestic consumption, then you get that value, and just dividing by the inhabitants and the total years, or divided by the 365 in order to get the liter per capita per day. So water demand patterns are very important in order to design the water supply network. uh, Ajmal Khan or Ahmad Khalil, if you have to ask a question, then you can ask through us, because I'm not aware of the chat basically. So if you have to ask a question, then you can ask me directly. Okay. So demand patterns are very important, because the demand just varies from city to city, seasonally varies. So it is also varies by day to day, by weekly, and similarly for hour to hour. So basically, in a year, I want to, okay, let me open one note. Okay, road problem. Okay, in a year, there's about 12 months. January, February, March, April, May, June, July, August, July, November, or December. So basically, in a 12 months of a year, mostly the demand is very high in these 3 months. And in 3 months, mostly the demand is high, like in a July, for example, in a July, you have to calculate this. That may maybe vary in these 3 months. So in a July, we have 4 months, 4 weeks. Two, three. So in 4 weeks, there will be 1 week that have a high demand. For example, in a second week, that shows a high demand of water. So in that week, there will be a day which will show a higher demand. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Saturday. So for example, the Friday day shows the high demand. So in that Friday, in 24 hours, there will be some hour which will show a higher demand. So basically, when we design a water supply network, we design that specific for this specific hour of a day, of a week, of a month, of a year that shows high demand. So basically, for that demand, we design a water supply network. So just I want okay. So basically, they are giving an example. If a demand registered during a particular hour was about 150 meter cube, and for the whole day, the total demand was 3000 meter cube. So the average hourly demand is about, by dividing the how much water you have supplied throughout the day and dividing by 24 in order to get that demand in per hour, use would be used to determine the peak factor for the house. So basically, what we do, that we calculate the peak factor for throughout the year. For example, for throughout the day, 1 2 3, about 24 hours, ranging from 0 to something value like 2. So we basically calculated the peak factor throughout the day in order to design a water supply network. So based on that, so the demand, for example, if you consider an example of our area in a Peshawar, mostly in a Peshawar, at from ranging from the 12 a.m. to the about 4 a.m., the demand is very low, like that, and I will just consider it as 0.6, for example. And after 4 hours, the demand is the people starting baking. So the demand increases due to the water using for the bathing purposes or for the prayers and something like that. So demand increases after reaching to about 10 hours. The demands again decreases, but where there the schools located or where there is colleges and universities, so due to that, in that junctions the demands increases based on the usage of water in that area. So after reaching to the 12 hours, the demand again increases. This basically for our region. So that type of the peak, the diurnal patterns basically varies from region to region. So in our areas, so as the time reaches to the 12 hours, so from the 12 hours to the 2 hours, the demand increases again. From the 2 hours it decreases up to the up to the 6 p.m. For example, I'm just assuming it. You have to just you have to experiment it and to find it. So basically in Pakistan, neither researchers have done such type of experiments in order to calculate that diurnal pattern. If you want to do a research in that, so you can also do a research in finding a diurnal pattern for the specific area as well. So from the 6 p.m., so the demand again increases due to the usage of water for the different purposes about the uh, 10 p.m. and the demand again decreases up to some value as it reaches to the 24 of, for example, again the 12 a.m. So diurnal pattern just throughout the area, it varies from time to time. So in that way, you calculated basically the peak factor. So these are basically the peak factor. The peak factor basically calculated by hour to hour. I will just show you an example at the last that how that peak factor is calculated. So this average value by dividing the peak value you used in some hour of the 24 hour, so you get the peak factor of that 1.2. So instantaneous demand is basically the demand basically required for a very small duration in a community for a short period of a time, or for a short used by the short number of small number of consumer of people. So that demand basically the instantaneous demand or the simultaneous demand. And similarly the flow, the instantaneous peak factor. So this is basically the same example as I explained here. So the simultaneity diagram basically shows that as the number of consumers increases, the peak factor decreases, because that as the number of people increases, for example, if 100 people of community, or there's a 10 people of community, so in 100 people of community, there will be some people having use water for usage, showing higher consumption of water. So while some of the people in these 100 population will be using water in a very less amount, so these values will be compensating each other. These type of people having a different usage of water, so causing decreasing the peak factor of the water, but ultimately having high number of people in that area having a high demand of water. But in a the demand of 100 people will be high, but the peak factor will be low, because in the compensating with each other due to the higher number of people. While for the 10 people, mostly, for example, if there's only one people having using, for example, 300 liter per capita per day, while other are using just 120, so that 300 liter per capita per day will highly affect the whole community or the whole peak factor of that water supply network. So this basically the diurnal pattern for the demand pattern in the Amsterdam. is basically taken from the municipal water company Amsterdam 2002. So this is basically the research paper from where they have taken that diagonal pattern. ओके ओके खलील भाई सा मसला बने हुई इंशाल्लाह हाँ ता सवा सही न दर्जी जी जुबल लिंक क्रिएट को महा दा खत्मी की